Good morning to you all. Already we know that the poles, any one of the pole is on the right hand side of the S-plane, then the system is said to be unstable. We know. Already we have seen for first order, second order, up to third order we have seen. We know how to find the poles of first order, second order, up to third order. But beyond that, it's very difficult to find the roots of denominator, that is poles of the system. That's why it's difficult to say the location of poles. So there is a procedure to find the location of poles, whether it is on the right hand side or left hand side or on the j omega axis. For that, there is a criterion called Routh-Hurwitz criterion. Let us see that. How many roots of the following polynomial are in the right of plane? Right of plane, left of plane, and on the j omega axis. That we have to find. Let us find by using Routh array. S power 5, S power 4, 1, 2, 2, 4, 1, 2. Now let us form MATLAB is there, Calc is there. We can find the roots. Why we need this method to find? Because those days there is no Calc, there is no software program to find the roots. So it is difficult to find lengthy procedure. That's why they found an alternate way. Now why we have to learn, you may ask? Because you cannot invent the wheel again and again. If you know this method, this can be implemented somewhere else. That is called research. That way we have to study all these things. So now we have to form S power 3. So 1 multiplied by 2 multiplied by 2 minus 1 multiplied by 4. That is 4 minus 4 divided by 2, that is 0. 2 multiplied by 1, then 1 multiplied by 2, again 0. So row of zeros. So what you will get is row of zeros. Therefore, we have to form the auxiliary equation. The auxiliary equation is equal to 2s power 4 plus 4s square plus 2 equal to 0. Therefore, dAE by ds equal to 8s cube plus 8s plus 0. Or we can write s cube plus s equal to 0. That is, the coefficients are s cube are 1, 1. Now we have to proceed further. S square. S square means what you will get? 4 minus 2. 2 by 1 is 2. Then 1 multiplied by 2 minus 0 divided by 1. Again 2 you will get. So s power 1 row. What you will get? 2 multiplied by 1, 2 minus 2, 0 you get. So again row of 0. Row of zeros. Already I told you that s power 1 means we have to consider row of zeros. Therefore, we have to second auxiliary equation. Second auxiliary equation is 2s square plus 2. Only even powers. Here also we have to consider only even powers. Because we have taken even coefficients only for that row. So here also we have to take even powers. Therefore, dAE by ds equal to 4s. Therefore, s power 1 is 4. S power 1 is 4. then s power 0 is what is that? 4 multiplied by 2 minus 0 divided by 4, that is 2, you will get it. So if you check the first column elements, if you check, write again s power 5, s power 4, s power 3, s power 2, s power 1, s power 0. What are the elements? 1, 2, 1, 2, 4, 2. No sign changes. No sign changes. No sign changes. But we cannot say the system is stable. Sometimes it may be unstable also. Let us check. Because it has auxiliary equation. What are the roots of auxiliary equation? Take this 2s square. Here, what are the roots of 2? S power 4 plus 4s square plus 2 equal to 0. This can be written as s power 4 plus 2s square plus 1 equal to 0. Or we can substitute s square equal to x. Therefore, x square plus 2x plus 1 equal to 0. Or x plus 1 whole square. X plus 1 whole square equal to 0. Now x equal to what? S square. This implies s square plus 1 equal to 0, or s square equal to minus 1, or s equal to plus or minus j. S equal to plus or minus j. S square plus 1 whole square. S square plus 1 whole square. Therefore, the roots are s square minus 1 minus 1. Repeated. Therefore, s equal to plus or minus j. Again plus or minus j. So if you plot this on the s plane, what you will get is plus j here, minus j is here. Plus j is here, minus j is here. Sigma j omega s plane. But again plus j minus j. Therefore, repeated roots on the j omega axis. Repeated roots on the j omega axis. If repeated roots on the j omega axis means unstable, the repeated roots on the j omega axis means, this we have already seen, means unstable. So single pole is permitted, but repeated. Two poles on the same point on the j omega axis, therefore the system is unstable. Even though there is no sign change in the first column, it's unstable. So we have seen simple case. First column element equal to 0, then a row of 0. 3 cases we have seen. That's all.